Number 83's directions are to condense this, so I need to move the number on the front back as a power, so, and then this back as a power. So I've really just got log base 6 of c to the 6th plus log base 6 of a to the 1/2, which is the same thing as the square root of a. So condensing them, I've got log base 6 of c to the 6th times the square root of a. And that is my answer. On 84, we're trying to condense again. We've got, I'm going to go ahead and just jump straight to the answer. Log base 8. I've got multiplication of x squared and y to the 5th, but then division. So I'm going to do a bigger set of parentheses and a fraction bar. So I've got x squared times y to the 5th, and then divided by z cubed. And that is my answer. On number 85, okay, so the directions changed to expand. So we're going the exact opposite way that we've just been doing. So I've got I've got a single log with two things being multiplied on the inside, so that means I'm going to separate them using addition. So log base 2, log base 2. There's going to be plus because of the multiplication. It's going to be a in the first one, and b in the second one, and then the powers have to go in the front. So this 4 should go here, and that 3 should go there. And that is the expanded version of that. Now on this one, you've got natural log of these two things being raised to like 1 power. So I have to distribute that power. So it's actually the natural log of a to the 5th over b to the 30th. You actually have to multiply. So my final answer is going to be natural log and natural log. There's division, so we're going to subtract. I've got an a and a b, so a goes in the first one, b goes in the next one. And then the powers are what goes in the front. So I've got a 5 in the front of this one and a 30 in the front of that one. And that is my answer. Okay. On 87, I've got 3 different terms, n, h, and q. So I'm going to have 3 different logs, log base 4, log base 4, and log base 4. We are multiplying all of these, so that is why we are going to add. So plus and plus. I'm going to put the variables n, h, and q here. And the numbers that go in front of the logarithms are their powers. So I'm going to bring the power, so m's power is 4. H's power is this right here. Remember, power on top, root on bottom. So that is the 3/4 power. So that should be a 3/4 right there. Q has no power, so you can put a 1 or you can just leave it. But that is my answer. And then on 88, I've got 3 terms, y, x, and z, so 3 logs. Log base 4, log base 4, and log base 4. We're multiplying and then dividing. So multiplying and then dividing means plus here, but then minus there. I've got 3 different variables, y, x, and z. And the powers are 2 for the y, so that goes in the front of the y, 3 for the x, and 7 for the z. And there we go. Alright, now switch gears into solving exponential and log equations. So this, I don't care about that, the rounding to the nearest thousandth. If you do a decimal, I need 3, but I'm not gonna type it in. I'm just gonna see what we got. Okay, if I have an exponential set equal to a number, then the best way to work this is to convert it into a logarithm. So log base, the base of the exponent is base of the, the base of the exponent is base of the log, so log base 11 of 93.6 equals r plus 5. Now log is an operation, so it's log base 11 of 93.6. That's the only thing inside the operation. So the last thing I need to do is get r by itself, which means subtract 5. And I'm going to subtract 5 from this side, but not from 93.6. You cannot do that. So the answer is log base 11 of 93.6 minus 5. If you don't put the parentheses, that's okay, as long as you don't then say 93.6 minus 5 and then do, what would that be? 88.6? Yeah, can't do that, okay? This is my answer. For this one, I've got an exponential equal to a number, so again I convert. Log, now, okay. What if I had 18 to the negative 3p plus 2 equals 71? You need to get the exponent alone first, like get this exponential term alone, so you'd have to subtract 2 first. If you had like a 7 in the front, you'd have to divide by that 7 before you could convert to log. But as soon as you have an exponential expression equal to a number, convert to a logarithm. So log base 18 of 71 equals negative 3p. Guys, you are not convincing me that you're working. Yes, well, you need to be. Everyone needs to be. I need to solve for p, so divide by negative 3. You're not dividing 71 by negative 3. You're dividing this whole expression by negative 3. Okay? So p equals, and you can say negative 1/3 times that, but if you just want to write it like that, that's fine. Divided by negative 3. Alright. Number 91. The exponential e to the n minus 1 is not alone. It's being multiplied by 2, so I need to get rid of that first by dividing. So I've got e to the n minus 1 equals 19. And so a couple different ways to do this. One is to recognize the fact that natural log and e cancel each other out. So I'm going to work this two different ways. Okay. One is how I would do it, which I know that natural log is the inverse of that. Natural log is an operation, so I'm taking the natural log of both sides, kind of like you take a square root of both sides. If you put a natural log on this side, that is very, 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 very wrong, okay? So natural log of e to the n minus 1 is just n minus 1, and that equals the natural log of 19. And so then I add 1, and so my answer is the natural log of 19 plus 1. Ugh, and that's it. Okay? Over here, I would convert to a log. So log, just like we did this, you know, that one right there. So log base e of 19 equals n minus 1. And then add 1. Log base e of 19 plus 1 equals n. But log base e is natural log. So natural log of x is log base e of x, just as a side note. Okay, on this one, I need to get the exponential expression alone, so subtract 4, and I'm left with e to the negative 8k equals 41. So I'm going to solve it the way I would, and I'm going to take the natural log of both sides, so natural log of this and natural log of that. Like I said, it's like a square root. You're taking the square root of both sides, you're taking the natural log of both sides. So I'm left with negative 8k equals the natural log of 41. And then we just divide by negative 8k, or not negative 8k, negative 8, and we're good. Now, you might have noticed over here that I left the negative on the bottom, and you know I don't like that. So if you wanted to, you could just bring the negative to the top and say negative log. So I would go ahead and say on this that the answer k equals a negative natural log of 41 divided by 8. Alright, number 93. So this can be solved using logarithms, but log base 3, because this is just a number. But it's also easy if I just think of it as 3 to the negative 3p equals 9, which is 3 squared. The only way 3 to the negative 3p equals 3 squared is if their powers equal each other, because the bases of the exponents are already equivalent. So I'm really just dealing with when does negative 3p equal 2. So divide by negative 3. And my answer is a negative 2/3. And there we go. Okay. Number 94. 243 and 81 are both powers of 3. So what I'm going to say is 243 is 3 to the 5th, but I'm going to bring it up as a negative power. So that is 3 to the negative 5 to the negative 2x equals. And then 81 is 3 to the 4th. So 3 to the 4th to the negative x plus 2. Now, the bases of 3 are equivalent now. But then I've got to remember what to do right here. When I've got something raised to a power and then I raise that expression to another power, I multiply these two. So this becomes 10x, and then this I'm going to have to distribute. So it becomes minus 4x plus 8. So then what I do is combine like terms. So I'm going to add the 4x over and I get 14x equals 8, and then divide by 14, and 8 divided by 14 is 4/7. So x equals 4/7. Alright, number 95. When you have two of these multiplied by each other, 5 to the n minus 3 times 5 to the 3n, I mean, think of it like in terms of just x's. If I had x cubed times x to the 5th, you would not say 3 times 5. You would say that's x to the 8th, because it's 3x's times another 5x's, that's 8x's altogether. You add the powers. So when I'm multiplying and I have the same base, let me add the powers. So this is equivalent to saying 5 to the n minus 3 plus 3n equals 5 to the 3 minus 3n. So the bases 5 are the same now, which means I can get rid of them. So I'm really just dealing with this equals that. Now I'm going to go ahead and combine n plus 3n. That's 4n minus 3 equals 3 minus 3n. I'm going to add 3n over, and I'm going to add 3 over. So I'm left with 7n equals 6, so n equals 6/7. Alright, number 96. Same thing. 3 to the negative 2x and 3 to the 3x, so that's 3 to the negative 2x plus 3x, and 243 is 3 to the 5th power. So I'm really just dealing with negative 2x plus 3x is x equals 5. And there we go. Number 97. Okay, now we switch into log equations. And so exponential equations, you do not need to worry about your answers being not an answer to the final expression. So, or to the original expression. It's only logs that you have to worry about, because logs of negative numbers do not exist. So we will be checking our answers for log equations. I've got log of this equals log of that. The logs are already equivalent, just like the base of this equals base raised to that equals base raised to that. So I'm really just dealing with the equation 4n plus 7 equals 4 minus 5n. Okay. So I would normally add the 5n and subtract the 7. So get all the variables on one side and all the constants on the other. So I'm dealing with 9n equals a negative 3. And then divide by 9. And n equals a negative 1/3. On 98, 98's a little bit different because I have two logarithms separated by subtraction, and it's not equal to another logarithm, so let's talk about what has to happen. So this side right here, two logs separated by subtraction can be combined using division, so I've got x minus 2 divided by 3 equals 2. And then I'm going to convert Brian, are you getting work done right now? Really? Stop talking. You guys, I don't want to hear any more talking. I also want I want everyone to focus. Michael, you know you've been talking this whole time. Thank you. So, I've got a log equal to a number, and just like up here when we were solving these exponential equations, when you had just like an exponential equal to a number, we converted to a log. Well, down here we have a log equal to a number, so we want to convert to an exponential. So we say 2 to the second power equals all of that, x minus 2 divided by 3. 2 squared is 4. So I'm actually dealing with 4 equals x minus 2 divided by 3. So to undo the division, we're going to multiply by 3 on both sides. And I'm left with 12 equals x minus 2. You know, I said I was going to check the last answer, and I didn't. I will in a second. And then I add 2, and I get 14. So 14 equals x. So the only x I have in my equation is this right here. And if I plug in 14, I get 14 minus 2, which is positive. All I need to check is that it's positive because I know it'll work then. And so I'm good. A positive inside the logarithm, not that the answer is positive. So like this right here, if I plug in a negative 1/3, 4 times a negative 1/3 is negative 4/3, and that's fine because it's plus 7, and 7 is larger than negative 4/3. So that would be a positive expression. 4 minus 5n, if I plug in a negative 1/3, that becomes 4 plus 5/3. And so that will work out because 4 plus 5/3 is a positive number. Okay? So last one. I've got 2 logs separated by addition. Okay. Which I'm going to combine using multiplication. So log base 8 of the first times x plus 4 equals log base 8 of 12. So once I have one log equal to another log, I can cancel out the logarithms and just solve this equation right here. So I've got x squared plus 4x, and then equals 12. I'm going to go ahead and subtract 12 over and set it equal to 0. So I want the factors of negative 12 to add up to 4, and that's positive 6 and negative 2, which means my answers are negative 6 and positive 2. But remember, I cannot have a negative inside the logarithm. So when I plug in negative 6 right here, that is just an x, so negative 6 will not work. When I plug in a 2, that's positive, and 2 plus 4 is positive, so x equals 2 is my answer. And that is page 12.